Alright, physics students, today's lesson starts with gravitational potential energy. So, you may be familiar with this one, and you'll be pleased to know it's not as tricky as the last week's work. So, the formula here is going to be EPG. So, we've got two little subscript tags. So, that reminds you that it's potential gravitational energy. And it is equal to mass times gravity times height. Mass has got to be in kg, so we'll always have to remember to convert that. Gravity will be 9.81 unless we're doing it on some other planet. And height will have to be in meters always. And our gravitational energy here is in joules, capital J for joules. Energy has no direction, so it's a scalar quantity, so we're not going to have to worry about direction here. In my question here, I've got the truck. It's on top of the slope, and it rolls down to here. For this particular question, we're going to work from the center of mass of the truck, which is its balance point, where I could balance it on my finger if I was very clever. Center of mass will not change no matter where it is. It's always the center of mass, so those are our points. We're interested in how much gravitational energy it has, which is exactly the same amount of gravitational energy as it loses when it does this transfer between these two spots. So we're interested in that height there, which turns out to be 35 meters. Okay, the mass of the truck is 2,200 kgs. And so we want to find out its gravitational potential energy here. Then we just go EP equals mgh, which is 2,200 times 9.81 times 35. So you can see that it gives a particularly big number, 755,370 joules. It'll be common for answers to be done in kilojoules or even information given in kilojoules. So this one here becomes 755 kilojoules because it's easier to write. But you also see we've only got two significant figures there. So this one here, best answer is probably 760 kilojoules, and that would be 2SF. Something like that. Now, the truck as it sits just here has no gravitational energy anymore. Unless, and you might find a question like this, unless somebody goes and digs a big hole. And now it's got a big hole down into a pit. So now it has the potential to fall again. And if it's got the potential to fall, then it's got gravitational potential energy. So we would be interested in repeating this calculation with this new distance, which is 68 meters. And so you just run the same calculation now to say that it could fall 68 meters, and that will be its gravitational energy at that point. Otherwise, it's fairly straightforward.